I made this example for my students so that they could practice identifying clean code violations and then refactoring in order to remove them. And we had some interesting discussions around it. I figured making a video would help complement some of those discussions. So I'll make sure all of this code is provided either in the video comments or provide a link to it. But let's take a quick look. We can see we have a grading tool, and it's going to map from well, given a numeric grade, give you the letter grade for it according to two different systems, the traditional system and the triage system. And I'll provide a link for those who want to read more about triage grading, but suffice it to say for now that it has a different mapping from percentile to letter grade. We've got a main menu which shows just a simple text UI, and we have a set of unit tests that use parameterized tests to ensure that the mappings are correct. So we can run all these tests, run all tests, and see that, yes, indeed, we're fine. So working together with my students, we identified several clean code violations, and some of them probably jump right out at you, like the fact that this is not a verb, and the fact that this has too many arguments. The really important ones here are the DRY violations, right? The don't repeat yourself violations. So here we have a block of code that is almost identical to this, just with a couple different values. But even within those blocks, we have kind of this repeated structure. And I was talking to my students about this today and said, sometimes you get these DRY violations. Very often it's because of the lack of an abstraction. And in the easy cases, you fix that just by introducing a new method. Methods are very easy abstractions to make. More often, though, the more common and maybe more challenging ones are these object-oriented problems. So we have a lack of a good abstraction, a good object-oriented abstraction for this problem. So what is one to do? Well, what I like to do in these cases is think carefully about what is the actual problem domain. What problem am I really trying to solve? And I think with a little bit of analysis, you'll come up with something like this, where you can say, well, mathematically, I have a range of numbers, and I have a mapping from that range to a letter. Right? If somebody asks you, gee, I got an 88%, what letter grade is that? Well, you don't say, well, first you make an if statement and then you have a bunch of else cases. No, it doesn't work that way. You say, well, you see which of these ranges it's in, and then you look it up on the table to see which one it is. So really, we shouldn't be satisfied with any software implementation that doesn't represent the problem domain. Right? If it's not a mapping from ranges to strings or from ranges to grades, we shouldn't accept it. It's not a good representation. So how do we move forward now? Well, we might need then some representation of what a range is. Now, we could write one, right? Of course, we could make our own class to represent the concept of a range, but we don't have to go to that much trouble. There's not one in the standard Java libraries, but there is one in Guava. And I've got a whole video about how much I like Guava, so I'll add a link to that. From here, you can go to Releases, and then go to the release page, and you can download the jar file. And I've done that already. So I've downloaded the jar file and I copied it over to a new lib folder here within my project. So once it's there, I can right click on it. I can say add as a library. Bam! It is now part of my project so that I can refer to classes within Guava. So let's just start working, say, in a constructor here because it gives us a place to write some code. So the range library is quite nice. We can say things like, well, here, let me bring that up. We can say explicitly, we can have a closed range. Whoops. Yes, sure, add it to get. Here we are. We can have a closed range from 0.9 to 1.0. That creates for us a range object. That object is exactly the highlighted bit there. And what we want to do is put that into a map. So let's see, what would be the next step? Maybe we can say have a map from range to string. And later I'd like to replace string with an enumerated type called letter grade, but let's just do one refactoring at a time. So let's call this my map. This is a new, let's just try hash map first. That's good for a lot of purposes. And we use Alt-Enter here to import that. And that looks good. So, if we had that, then we could say map.put, there's a range, and here is my letter. Then I could say map.put, range.closed, 0.8. Sorry, this is a closed open range, because it's closed on the bottom, open on top. And that's going to map to B. And I could do that, right? I could keep putting those in. It looks a little bit redundant to say map.put each time. It turns out, again, there's a really handy class in Guava called Immutable Map, which we can use for a map that is initialized once and never changes. So we can make an immutable map of. There it is. And of just takes a bunch of key value pairs. So there's a key and a value. There's a key and a value. And let's see if we can get the rest of those in there real quick. 7 to 8 is a C. 6, 5, for some reason, to 7 is a D. And let's see, this will be closed, open again, from 0 to 0.65 is an F. And, format the code. There we are. Mismatch parentheses, right? Mutable map of, how about if I actually put the parenthesis there? There we are. And we'll import that. Good. Shift-Alt-L to format the code. And there we are. So this is a map. Map is kind of a placeholder name. Let's call that the conventional grade map. And in fact, I don't really want that in a constructor. I'll just make that a constant here. Oops. Uh-oh, lost it out of the clipboard. Luckily, I'm using Linux, and I have a smart clipboard. There we are. And if this is now a constant, we'll call it conventional grade map. So we can follow the Java conventions. Neat. And you know, if you don't like having to specify this, right, if you think, well, that still looks like too much code, well, I'd say maybe you need to take it a little less seriously. But you could write a domain-specific language that would parse out exactly this, right? You could actually write a program that reads that and constructs it into a grading scheme. That seems like too much work for what we're doing. I think this is a pretty good solution. Let's see. So we could go ahead and make another one of those from range to string. This will be a triage grade map. By the way, at this point I'm getting a little nervous because I've been writing a lot and I haven't run my tests again. And that's a feeling you want to try to foster in yourself, right? If you're doing a lot of typing and not running the tests, maybe you're doing too many things at once. But after all, this is an instructional video, so we'll just move on. All right, so I'll need these numbers. We have a range that's open, closed from 8/9. And we have to make sure that's going to do the floating point math for us. Oops. Here is our range, 8/9 to 1. There we are. That looks good. Then we have a range that's open, closed from 13/18 to 8/9. And that'll be our B's. We have a range that's open, closed, 8/15 to 13/18. Gee, now I'm wishing that I had that little program that would just parse my other solution for me. Open, closed, 1/3 to 8/15. And, you know, I remember I've got to put those dot zeros in there. But let me just get this all typed in. This is closed from 0 to 1/3. Stick the dot zero in to force it to use floating point, and that'll be an F. All right, let's go clean these up. We got our point 0, got our point 0, point 0. Now, you might say, but Dr. G, look at the repetition of those constants, 13/18. What if you accidentally type it wrong somewhere? And if you're saying that, you are exactly right. All right, that's dangerous to have these numbers just floating around there and hoping I type them right. They really should be constants too. But one refactoring at a time. So you can hear me writing on my to-do list, refactor those constants. Okay, so I've got these two maps set up. I don't really need that constructor. What does that let me do here? Well, for triage grading, for conventional grading, we can get rid of all this. We can say for every range R that is in the conventional key set, let's check to see if that number is in the range. If R contains numeric grade, if that's true, then return whatever that mapping is for that range, right? Which is the equivalent of, there it is, grab whatever row it is and look up the mapping. And that's pretty straightforward. So we got rid of all that repeated logic of this basically, and we replace it with something like this. Well, that's pretty neat, isn't it? Let's run the tests. Oop, look, I got a compiler error here. What did I get wrong? Let's try formatting, see if that helps us. Oh, we have some cases that don't return. If we get this far, we have a problem. So illegal argument exception, no mapping found for numeric grade. Good. Now, ideally, that should never happen. Famous last words. Ooh, neat. Double cannot be cast to integer. Line 64. Oh, it looks like that's the has to do with these range, the way the ranges are built. So let's just go double check that. Maybe it doesn't like that. Again, I'm not entirely sure what it's unhappy about. Let's check. Double dot compare to range. Well, this is the line of our code that it is, right? So this is all library code, but this is where it hits our code, right? So we click on that. Say 8/9 to 1. Yeah. It needs to do strong type checking, and it doesn't want to infer the type. Oh, nope, still not there. 24. Maybe that's the last one. Hey, nice. Okay, so our mappings are still all correct. That's good. We got rid of the internal DRY violation here, right, where we had the idea of this cascading table of values was represented in way too many pieces. Now we have one place it's represented in these maps. Now, once we have the maps, we have a generalized abstraction that any mapping can be done in this way, from range to string, right? These are two specific mappings. So we could do something like this. If I have a map from range to string called let's see, the map I want to use. There's a couple ways we could do this. Let's do this verbosely first. We can say if we're using triage, then map is triage grade map. Otherwise, map is conventional grade map, which then lets us get rid of this and all this redundancy, and instead just say, well, we're dealing with whichever mapping it happens to be. So clean that up a little bit. Well, that's pretty nice, isn't it? Because now we're just saying, hey, which map are we going to use? Use it. The beauty of abstraction. Now, if you like, you could condense this even more if you're comfortable using Java's ternary operator, which I am, so I'll show you. We can say if we're using triage, then use triage map, otherwise use conventional map. And then we don't need this anymore. There are pockets of developers who prefer not to use this notation because they find it strange. There are other developers who say, well, it is what it is. We don't mind it. So I happen to be in that camp. If you don't like this, you can just go back to the other form. Again, run our tests. And that looks pretty good. So that's a nice way to handle some of the refactoring problems here. There's still a couple of other clean code violations, but I think I'll leave those as an exercise for the reader. Thanks for watching.